Now, that kind of lends itself to the distributed nature of blockchain. So, although ledger technology has been around for some times, and even simple ledgers, blockchain takes advantage of it by having a single source of truth and has a distributed nature where everyone has the same copy of that blockchain. Next, let's introduce the fact that blockchain is immutable. To do so, let's dive into the pieces that make up a blockchain. So in a block, we have three major pieces. First, we're going to have the transactions. So these are going to be all the transactions that occurred when that block was created. In addition, there's going to be a hash. A hash is essentially a digital fingerprint. So it represents the transactions that are in the block and is completely unique. So if any of the transactions were to be changed, the hash would also change. So let's pick a couple of letters for the hash. Generally, it's an alphanumeric sequence that's usually a lot longer, more secure. It's also going to have the hash of the previous block in the chain. So let's say we're right in the middle of a blockchain here, and we'll pick something for the previous hash, say maybe 2a. And so now let's move on to the next block. The next block is going to have its own set of transactions, as well as the previous hash, which corresponds to this one right here, as well as its own hash. And so on and so forth, we can kind of extrapolate all of the hashes and previous hashes. So you can imagine that if you were to want to tamper with any of the transactions that have occurred or change it, so for example, to change one of the transactions, this one, the hash would change. And because of that, the previous hash of the next block in the chain would now be incorrect. So to fix that, you would have to tamper with every single block in the chain, and that would immediately become apparent.